All right, so we are going to be doing something a bit different today. Um, in the classroom post for today, there should be a file. I believe hrdiagram.png. Um, I want you to either, you can choose whichever you want for this, either print that, okay, so print it out as like a actual piece of paper, or if you don't want to do that, you are going to be writing on it, or you could save it and open it up in like an image editing thing. It could just be Paint, like it doesn't have to be anything fancy. And basically, you're either going to be writing on this in paper, or you are going to be marking this using like an image editing software. So whichever one you want to do that. Also, make sure to either write or type your name on on it as well. So again, either if you want to print this out and work on it, or save this and edit it on the computer, you are turning this in. So again, think about whichever one is easier for you to deal with and um, be able to upload. So on in the classwork tab of Classroom, there is an assignment here basically for you to like submit this. So again, that would be either if you just have it, if you have downloaded it as an internet file, PNG, whatever, and edited it that way, you can just upload that. Or if you did it out on a piece of paper with pencil or whatever, then you can just take a picture of it and then submit that as well. So either one of those is fine, just whichever you are most comfortable with. So what I'm going to have you do is this is a PowerPoint that is I'm going to give you a bunch of stars. Okay, and basically going to give you the stars and their spectral class. And from that, I want you to basically think, where do they go on this diagram? Okay, plot this on the diagram. Now, this is again, I'm not expecting you to get this all right. So again, try this earnestly. Don't skip ahead and put them all in. Like, I don't care if you get this right or not. For now, right? You will have to do this later on, but as like a test, for example. But for now, this is just to see. You're testing yourself to see basically how well you think you might understand the classification stuff. So don't worry about like if you get everything wrong. I'm not going to take points off. The point is just to do this and see what you can get. So basically, I think there's 30 stars. There's a lot. So what you're gonna do is the first one you say number one, and then put where you think that star is on the diagram. Label that with a number one, and then you'll put number two and label that with number two and three and so forth and so forth. So let's see how this goes. So I'll wait until you're ready for this. Either you've printed it out and you have it ready, or you've downloaded it and opened it in some image editing thing and you're ready to go for that. So pause this until you're ready, and then we'll get started. All right, so your first star to try to plot on this diagram is the sun. So the sun is a G2V, I'll say V, Roman numeral 5, whatever, G2V star. So think about G2V, where should that go on the diagram, okay? Remember how the letters are actually listed on the bottom of the diagram, so that's helpful. And then remember how the numbers work with that. And then the main thing that trips people up is trying to remember how the Roman numerals work. Okay, so just think about this, see what you can get, and once you think you got a place for it, again, mark it down, kind of draw a little circle or whatever where you think it is. There's a little wiggle room here, obviously. It's not going to be precise. And then label it wherever you spot you put it, label that with a number one. Okay, so make sure you know which one it is. You probably don't want. You might think, oh, I just write in sun. A lot of these star names can get kind of long, so there probably isn't enough space to write them all in. But whatever to you. So okay. All right. If you think you have it, here's about where it should be. So get the mouse here. Now the sun actually, you can get a bit more precisely. So again, it's within the G band. So again, the G band means it goes all the way up to here. And you can see the lines here also line up with these. So it's within this rectangle, basically. And G2 means it's on the left side of that. Not all the way to the left, but like, about here. So If anything, I'd probably move it over a little bit more. And then the V, Roman numeral 5, means that it's within this main sequence. It's within this main band. So basically, wherever in this rectangle is, that's in this main band, again, like over on the left side a bit, that's where the sun is. Now, the sun also, the luminosity scale over here, the sun actually is by definition 1. So if you want to be precise, actually should just line up with that number there. But again, it doesn't matter. So somewhere around in here. Don't worry about it being super precise, but it should be about there. All right. Now you have 3 stars here. So plot these all out separately. So number 2, number 3, and number 4. We have Alpha Centauri A, which is also a G2V star. Alpha Centauri B, which is a K1V star. And Proxima Centauri, which is an M6V star. And you can see this sort of sizes and shapes of all that. So, yeah. This is the nearest star system to us. Okay, so the nearest star system, I think I mentioned this earlier, either Tuesday's video, maybe? I don't remember. But yeah, we have a triple star system closest to us. The 2 Alpha Centauri stars, they orbit each other. I think they're about the distance apart that Saturn is from the sun. I think that's what it is. And then Proxima Centauri orbits both of them. It's really far out. I think Proxima Centauri orbits its stars in 10,000 years or something ridiculous. So yeah, but they are gravitationally bound. So there you go. Once you have these in place, and again, label them 2, 3, and 4. And then we'll move on. All right, yeah, so I've kind of labeled them here. So, again, Alpha Centauri A is also a G2V, just like the sun. So it should be in pretty much the same place as the sun. Now notice I've moved it up a little bit. The main reason for that is that you can kind of just see by the image here. Even though it's technically the same class, that doesn't mean it's exactly the same, right? It's just within the same categorization. The Alpha Centauri A is a little bit bigger than the sun, is a little bit yellower, a little bit brighter, right? So it is, if you want to be technical, it is going to be a little bit higher up. But still, again, these are all 5, right? Roman numeral 5. So they're all still in this main sequence. Alpha Centauri A is basically where the sun is. Alpha Centauri B is on the left side of K, because it's a K1, so it's going to be on the left side of the K region. And then Proxima Centauri is M6, so a little bit to the right of the middle of M, down in the main sequence. Notice, even though, again, these are all Roman numeral 5, that doesn't mean they're all in the same place vertically, right? It's just that they're within this band. So wherever that lies, that's where they end up going to be. Right, next up, Barnard star, M4V. For 5, label this in there. You may imagine it's M4V. Proxima Centauri before was M6V, so it should be kind of in the same place. So, Proxima Centauri was an M6V, so down here. Barnard star, M4V, a little bit more to the left. Again, I have it a little bit up. I don't know precisely which one is, So if you have it they're both here and here, whatever, I'm not going to be super picky about it. So, yeah. Well, again, for this assignment, I'm not picky at all. But in terms of a test or whatever, I'm oh, you were not exactly right here. Oh, then you're wrong. No, right? But yeah, you had it here. Well, then no, because then it's not on the main sequence, right? Or if it's over here, then it's not in the M column, right? So yeah. All right, another pair here. We have number 6 and number 7. We have Sirius A and Sirius B. So Sirius A is an A0V, and Sirius B is a B1, and that's white dwarf. So again, that's how I write it. I've seen it right like that. Also, if you remember, sometimes people use Roman numeral 7 for white dwarfs, but anyway, it's a B1 white dwarf. So Sirius B, B1 white dwarf, and Sirius A is an A0V. Okay, so A0V, again, it's still in the V means it's still in the main sequence, so it's going to be right on the very left side of A, so A0B, or A0V. Now, Sirius B, again, it's a white dwarf. It's a B1, right? Yeah, B1 white dwarf. So the white dwarf is basically in this region here. So B1, I picked there, but again, if you had it like down here, then that's fine. I think I plotted this one on a point actually. Yeah, I specifically plotted it on this point here. It doesn't have to be there though. It could have been lower or whatever. So yeah, there you go. So yeah, the white dwarf. It is hotter than uh, the other one, but it's much smaller, so it's much less bright. And yeah, okay. Here's another pair. We have Procyon A and Procyon B. Procyon A is an F5V, and Procyon B is an A6 white dwarf. You can see here's a comparison. So size-wise, Procyon A is noticeably larger than the sun. It's also a bit brighter and hotter. And Procyon B is actually smaller than the Earth. So yeah, we haven't really talked about white dwarfs fully yet. We're going to be doing that next week. But yeah, white dwarfs are often like the size of Earth or smaller. So that's something that's kind of interesting. Make sure you're labeling these, by the way. So these are number 8 and number 9. Okay, so we had, what was it? It was F5? Yeah, F5, so right in the middle of F here. That's going to be A, again, still in the main sequence. And then your white dwarf here is A6, so over on this side here. A6, get rid of the B1 that was over there. So another sort of pair of normal star and white dwarf. Okay, next up, Altair, A7V. I think, wait, where was... Oh, never mind. What was I thinking of? I don't know. Oh well. Yeah. Okay, so Altair, A7V, again, the V still in the main sequence. A7 though, so 7, a little bit more to the right of the A, up here in the main sequence part of A. So all these besides the white dwarfs have been in this main sequence line so far. Okay, so everything should be in this main sequence line. That's what the V is telling you, somewhere in this line. You have another one, Sigma Draconis, K0V. Okay, so Sigma Draconis, again K0, is going to end up on the left side of the K column, still in the main sequence, right about here or so. Again, maybe a little bit lower, higher, whatever. Not a big deal. We're going to get out of the main sequence at some point here. But not yet. Number 12, 61 Ursa Majoris is a G8V. Okay, so here, again, it's on the right side of G, in the main sequence part of it. So it's very close to the last one, right? But the last one was just over the line for K. This one's a little bit back over for in G. Again, still in the main sequence. I think what I did is that all of these stars, I think I ordered them in terms of like how far away they are from the sun. So a lot of the smaller ones are that we can see, of course, are going to be closer because we're not we can't see like a white dwarf. Well, I mean we can, but they're not easily seen like out, really far away. Actually, random side note for that. The brightest star in the sky, obviously after the sun, is actually Sirius, because it's pretty close to us, and again, it's an A0, right? So it's pretty bright. It's up here, so it's about 100 times brighter than the sun or so, and it's fairly close. That's why it appears to be the brightest star in the sky. The closest star to us is again Proximus. Proxima Centauri actually is the closest one right now. In several thousand years, it will actually have orbited further away. But even though it's the closest star to us, because it's so small and dim, we actually cannot see it with like the naked eye. So you can see the Alpha Centauri system, but you cannot see Proxima Centauri like next to it. It's too dim to see. So again, that shows kind of how that works there. I believe they're in the southern hemisphere though, so I don't think we can see them anyway. But yeah. Where were we? Yes, okay. Oh, different Roman numeral. So, number 13, Pollux, K03, Roman numeral 3, K0II. And this is sort of your size comparison with the sun, so we gotta get into some big boys. So now it's not on the main sequence, because it's not a Roman numeral 5, so where is it going to be? So Roman numeral 3 corresponds with the giants. I put it here. So it's K0. So again, it's on the very left side of the K. So it's this sort of region here is the giant region. Okay. So and he starts here, and also it stretches a little bit over to here. But if you notice, there aren't really any place region here where there's not any dots on it. That means that there's just not really stars that fall into that section, right? So you can see there's like no star that's over here. That means there is no M star that is going to be about this bright, or there's no G star that's this bright, or no A star that's one that's very like this bright. And there, some, especially up in here, there are some stars that fall into here, but they're very rare. So this can sort of help you figure out, well, for example, a star that you plot is probably not right here because there's no dots right there. So for some reason I did put this. I think when I originally made this, actually, I was slightly confused about something. So a lot of the ones that were Roman numeral 3, I put it like the very bottom of this plot, which is not really true. So if you put it like in the middle or near the top, that's fine. But yeah, so somewhere along in the giant region on the very left of the K, because the Roman numeral 3 says. Next up, Arcturus, K-O, Roman numeral 2. Okay, and here's your comparison, right? So Sun, here's your Sirius A, here's Pollux that we just looked at, which seemed really big, and then here's Arcturus, which is a lot bigger. This is now K0, Roman numeral 2. You have to think about how is Roman numeral 2 different from Roman numeral 3. Okay, so Pollux, the Roman numeral 3 one, that was, again, in this giant group around in here. This one, I think I drew this one not exactly correct. I made this a few years ago. So, yeah, okay, this should be higher. Okay, so this should be up here. Okay, so this one, which was number 14, yeah. So when we get to the end here, number 14, it should be above this main giant region. So like maybe right about here or so, it should be about there. So yeah, so you can see there's these sort of like scattered group of stars sort of between where it says the main giant group and also where it says super giants. So between those, this is your Roman numeral 2 position. So I know the ones that I made for Roman numeral 2 are kind of off. So there's a couple of those. So yeah, this one should be higher about here. So next up, number 15, TRAPPIST-1, an M8V star. So it's pretty small. See, compared to the sun. M8V. Alright, so M8V, it's all the way on the right side of M, and V tells you that it is in the main sequence. So it's all the way down here in the right. TRAPPIST-1's a very small star, but it's a very interesting star because it has 6 or 7 planets that orbit it. So it's very interesting that when we know about those, and at least 2 of them are potentially habitable, maybe 3. So yeah, really interesting star system. All right, now we got something a little bit interesting. Regulus, a B8 Roman numeral 4. So the Roman numeral 4 is a little weird. Not many stars fall into this category. So think about how that relates to how that's different between Roman numeral 5 and Roman numeral 3. Okay. So B8, so it's going to be on the right side of B. And the Roman numeral 4, yeah, I told you that 4 is basically just a little bit above the main sequence. So, like, maybe this one, maybe these stars right here. See, there's kind of this, like, clump of stars here that's sort of a little bit off the main sequence, but it's not really in the giant group. These are probably 4s. So there's not many 4s it's so I just put it like a little bit above the main group. So I wouldn't put it like I wouldn't really put it up too much higher. Maybe put it a little bit higher. That's okay. But like up here, no, I wouldn't put it up here because that would probably be like a 3 or 2. But yeah, so a little bit above the main sequence. All right, number 17. Apparently this is pronounced. I learned recently it's Aldebaran. So yeah, um, it's a K5 Roman numeral 3. Place that where it should go. Yes, okay, so again, K5 right in the middle of K, in this giant group here. Again, I probably should have put this a little bit higher, but it's fine. So within this giant cluster in the middle of the K column, where Aldebaran goes. Again, make sure you're labeling these with the numbers. Okay, so that was number 17? Yeah, 17. All right, moving on, number 18. Achernar, a B6V. So again, back to the Roman numeral 5. It's in the main sequence, but it's B6, so a little bit to the right of the middle, up in the main sequence. Compare this to what the Regulus was the the B8-4. So oops. Yeah, a little bit to the right and a little bit up compared. Okay, anyway. All right, 19? Yeah. Spica? I don't know. Anyway, whatever. It's a B2V. The previous one, Achernar, was a B6V. This is a B2V, so it's going to be further along on the left side of B, up in the main sequence still. All right, number 20, Zeta Leonis, F0 Roman numeral 3. This one's a little bit finicky in terms of like finding a good place for it, but it's because it's kind of again once you get out of once you get toward the left side of the diagram in terms of distinguishing the Roman numerals between like Roman numeral 2 and Roman numeral 3 and Roman numeral 4, it gets really hard to like distinguish them. So yeah. All right, so Zeta Leonis, number 20, should go, yeah, about there. So it's an F03, so on the very left side of F, and up C. So it's sort of, see how this is the main group of giants, but they sort of trail off over here. So this is kind of on the trail end of the giants. And you may think, well, wait a minute, you kind of said that the fours are kind of here. It's like, yeah, they are, right? So, for example, if you gave me this plot instead and asked, what classification is this, I would probably say F03, but like it could be F0. If you said, I think it's F04, I'd be like, yeah, maybe, right? So it's hard to really tell at that point. So if you put it maybe a little bit higher, then that's okay. But I wouldn't put it like to this point. No, it's too high, definitely. But like maybe a little bit more. I don't know. Right, number 21, Mira, M7 Roman numeral 3. So Roman numeral 3, it's in the giant region. M7, so near the right side of the M column. Over there. So M7 up here, right side of the giant column. Next up, Canopus, A9 Roman numeral 2. So this is another one that's a little bit weird. Kind of hard to place. It actually, well, never mind. I'll save that for. Put where you think it is, and then I'll tell you what I was going to say. Okay, so what I was gonna say, let me go back a little bit, is that we had so F03. Okay, and so F03, the very left side of F in 3. And so this is A9 2? Yeah. So it's on the so A9 is the very right side of A, and it's a 2. So if anything, these two should actually be very close to each other. It's just this should be a little bit higher. Yeah, A9 2. I think you should probably have it maybe a little bit higher. And it's not really that far to the right. Probably should have made it a little bit further to the right. Yeah, probably should have had this a little bit closer. But yeah, whatever. Again, there's a wiggle room here, so don't worry too much about it. Yeah, it should be. It should be a little bit higher. It should definitely be like not in this giant group here, so it should be a little bit higher than that probably. And probably a little bit more to the right, just because it's not exactly. It doesn't really look like it. It should be a 9. This looks like it'd be more like a 7, but whatever. Okay, number 23, Polaris F71, Roman numeral 1. This is the North Star, actually. So, yeah. Is it Polaris or is it Polaris? I'm not sure which one, because it's like, I mean, it's like polar, so Polaris, like, it sounds stupid. I think Polaris sounds cooler than Polaris, so I just say Polaris. I have no idea. There's a band named Polaris, or Polaris. See, I just go back and forth. Anyway, there's a band named Polaris, and they're pretty good. That's all I got to say. I don't know. They're Australian. So it's a 1. Roman numeral 1 is up here with the Supergiants. And so it's F7, right? F7, right? Yeah. So it's a little bit to the right of the F, all the way up here in this main Supergiant range. So yeah, it's a big one, big and bright. So Polaris is quite large. Hence, yeah, it's big and bright. So even though I mean, not super far away, but it's further away than all the previous stars you mentioned. But because it's so big, it's quite bright and we can see it very easily. Hence why it's the North Star, right? It's easily identifiable. Next up, Rigel, a B8 Roman numeral 1. I think it's Rigel. Maybe Rigel? Rigel sounds better. Better be labeling these. At least with numbers. Okay, so again, Supergiant still, so it's pretty high up. B8, so it's going to be kind of on the right side of B. Yeah, so the Supergiants. So again, notice how the main sequence, it very much is this sort of curvy line this way. The giant region is sort of flat, but it does sort of curve up a little bit kind of when you get to the end. For example, if I gave you like, I don't know, a B5 Roman numeral 3, it would kind of curve up to like here-ish, right? It wouldn't just like go straight into here. But the Supergiant block is basically just sort of a straight line. It's just sort of, here's anything that's at the very top here is a Supergiant. So Roman numeral 1 is just kind of this straight line. Roman numeral 5 is this diagonalish line. Roman numeral 3 is sort of straight, but then curves up over here. And then 2 and 4 sort of curve along, following between the two. Number 25 is Betelgeuse. That's how you say it. M2 Roman numeral 1. This is the star that has been in the news a bit recently because its brightness seems to be varying like weirdly, and so people are thinking it could be nearing its supernova time. But most people don't think it's like actually going to supernova like in like today or something. They say, oh, it's likely could supernova in like a few thousand years, So yeah. Not looking super likely that we'll be able to see it. That said, if we did see it, it would be brighter. It would be visible during the day and would look brighter than the full moon. So that's pretty damn cool. And it would be visible in the sky for like a month. So yeah, that'd be pretty awesome to see. It's not gonna like cook us with radiation or whatever. It's far enough away, so it's not going to be damaging, but we will be able to see it. It would be pretty impressive if we did see it. There was actually a supernova that was seen in 1054 AD. It was a star that exploded, and people could see it. There's some painting actually that like was this kind of famous painting of like a cityscape, and then there's this thing in the sky, and people are like, "What the hell is that?" And they're like, "Oh, it was that supernova that must have happened at the time." And there's other records of like all over the world of it happening. They didn't really know what it was. They were just like, "There's a thing in the sky." Oh, what? You know? But yeah. But we figured out what it was, and we traced it, and it's what we see now is the Crab Nebula. So that was something that exploded about 1,000 years ago, and people saw it. So yeah, it's pretty cool. Anyway, so again, supergiant, so it's up on the top, and it's an M2, so it's going to be over on the right. M2 on the right side here. Remember that size for stars, the radius, how this scales, that the smallest is down here and the biggest is up here. So these stars up here are the very biggest ones. And I think this next image kind of shows that off, right? Yep, because now we're on to Antares. So you can see, remember how we had an image of Pollux and Arcturus looking really big compared to the sun? Well, here's Rigel, Aldebaran, Betelgeuse, and then Antares is even bigger. It's an M1, Roman numeral 1, and it's absolutely massive. It's not the biggest star, but it's very big. The sun is like really tiny there. Okay, well the previous one was an M2I, right? Yeah, so this is an M1I. It's slightly to the left of it. I put it noticeably higher up, just because since again the size scales like with lines like this, that means that it should be higher up if it's bigger, right? But again, if you put it like just literally right next to it, like that's fine. I'm not that picky, so yeah. Just 4 more left. Yeah, number 27. Ah, yes, the boy star on Elam. Where is the boy? Plot boy. And you know, so that we have the boy star, there's also a boy star and a boy star. So it's great. Isn't astronomy great? Who says we don't know how to have fun? All right, the boy star is going to be over here. So again, it's in the supergiant still, so it's over in this left side at the top. It's a B0, so all the way on the left here of the B column, all the way up there. Okay. Number 28, S. monocerotis, which sounds like a disease. It's an O7 V. I think this is the first O star that I have you plot. I think it's the only one. O stars are very rare. They're like something like 0.0003% of all stars, something like that. Yeah, I think. Let me see if I can remember. I think it was like 70% of all stars are M stars, and then like 20% of all stars are K stars. Like 5% of all stars are G stars. Like 1% of all stars are F stars. Like 0.1% of all stars are A stars. Like 0.005 are B, and like 0.0003 are A or O, something like that. I think that's what the numbers are. So yeah, the vast majority of all stars are M stars, and the vast majority of all stars are like K stars. So actually, when people talk about how the sun is like an average sized star, it is if you were to like, again, if you look at the diagram, it is right because the sun would go kind of like right in the middle here. So it's like like half the stars are bigger and half of them are smaller, but like they're not because the vast majority of all stars are over here. So the sun is bigger than like 90% of all stars. So yeah, it's just that almost every star is like way smaller. So anyway, S. monocerotis is so it's gonna be all the way on the left, and it's in the main sequence though. So it's an 07, so it's in the main sequence. But notice again, 07 Roman numeral 5. This is Roman numeral 1, and they're like pretty close to each other. Okay, well I skipped ahead. No, well, just ignore that. So And that's because all of these lines, again, the 5, the 4, the 3, the 2, and the 1, they all just sort of converge in the upper left corner. And so that's where, again, it's very difficult to sort of separate them out. So, yeah, don't worry too much about that, especially when you get up here being like, oh, if I put it here, is he going to think it's a 2 when it should be a 3? Like, whatever. It doesn't matter that much. Okay, 29, we're almost done. Deneb, A2I. Great big star. Not as big as Antares. Okay, another supergiant. In the supergiant cluster, again, if you're at the top, A2, so on the left side of the A region, somewhere up here, again, maybe I wanted to be a little bit better. I probably should have moved a little bit to the right and a little bit up, but it's fine. All right, and the last star, number 30, is Vega, A0V. A0V. Okay, make sure you have it labeled as number 30. A0V, so this one, again, A0 on the very left side of the A column and in the main sequence. One thing that's interesting, so remember how I said the sun should line up perfectly with like 1 luminosity? Vega should line up perfectly with 0 magnitude. For some reason, Vega was chosen as the star to have a magnitude of 0. I don't know why. It doesn't make any sense to me. I think, I mean, even if you maybe say, oh, well, the sun is like too close to us, so it's like weird. Okay, fine. But like, I don't know. Polaris would make more sense. It's the North Star. You just pick Vega for some reason. It's like it's the closest star to us. I don't get it. I don't know. Whatever. Yeah, but there you go. There it is. So all of them together should be something like this. I do know. Let's see. I think this one should be up higher. 14 should be up higher. Should be about here. And then I think 22 should be a little bit higher. Which one was 22? Yeah, 22 should definitely be higher. Basically, the 2s should be higher. Roman numeral 2s should be higher. So 22 should be higher up, and 14 should be higher up. But the rest of it looks pretty good. Again, so yeah, this I'd probably put here, and this one I'd also put about here. So, but this is kind of what you should get here. In terms of the labeling of everything. Again, if you were not perfect, again, I'm not even perfect, right? I would have said 22 should be higher and 14 should be higher. That's fine. And again, for this assignment in particular, I'm not grading this. See, oh, did you do it right or not? I just wanted to see how well you could do this and just figure out how this works. And I don't know. It's one of those things that's like, people tend to struggle with it because it's just kind of confusing to think about this a bit because it's not like I'm really giving you like X and Y coordinates. It's not really like that. So you just kind of got to get used to this and see how this all lines up, and hopefully things start to kind of make sense. So, yeah. So once you have this kind of thing, basically, again, make sure your name is on it. I don't know, write it like up here or something. Then save this as an image file if you're doing it that way, and upload this to the classwork, to the assignment and the classwork. And if you did this on a piece of paper, take a picture of it and upload that picture as well. So, yeah. And you will have to do something like this on the final to some degree. You don't want 30 of them, but you will have this on the final. So just keep that in mind that I am going to expect you to be able to do this at some point. So this is sort of a practice for that to see how well you could do. Okay, I think that's the end, right? That is the end. So, here was my simulation of a lesson in real time, I guess. And hopefully it worked somewhat. And you didn't just skip ahead and just get to this and then just fill everything in, because that defeats the purpose. Also, don't try to just like screenshot this and pretend that this is your own thing, because come on, dude. Like, really? I'm not that dumb. Alright, let's see, Monday. Well, we will have a Kahoot on Monday, and also we will get into stellar remnants. So white dwarfs, neutron stars, black holes. How exactly do those form? What exactly are they? How are they different from each other? Maybe some similarities. stuff like that. So that's we're gonna get new Monday. All right, I'm done.